Hello, my name's Rowena. I provide mock Oxbridge interviews for OxFizz. I read chemistry at Oxford from 2007 to 2011 and then completed my PhD in Birmingham in 2014. I've now done around 250 interviews for OxFizz in the physical sciences. OxFizz is a not-for-profit social enterprise which provides practice interviews for Oxbridge applicants, as well as offering other academic support, such as summer schools. The interviewers are Oxbridge students and graduates, like me. Mock interviews encourage and prepare future applicants for the Oxbridge experience and empower volunteers. This video is about personal statements and how your interviewers might use what you've written in your personal statement during the interview. I'll be using short, anonymous extracts from real personal statements. Remember, the aim of the Oxbridge interviewer is to make you get stuck, see how you deal with it, and then try to help you get unstuck. We don't care if you get the right answer. We want to know how you problem solve, that you love your subject, and that you don't give up. This is a trial tutorial, not really an interview. Spelling, punctuation, and grammar. In a physical sciences interview? Really? So, no, I'm not going to test your spelling, but I will use it to pitch the level of the interview. If you haven't used a comma in 500 words, think that any vaguely important word should be capitalised, right? Or can't spell one of them, I'm going to assume if you haven't checked your personal statement, you also haven't checked the facts you're claiming to know. Optical activity does not need to be capitalised any more than sporting activity. If your spag is bad, I'm going to pitch the interview lower and assume you don't have as much background knowledge. If you are in fact a strong candidate, that might mean I never get round to really stretching you, and if I can't stretch you, I can't prove that you're any good. So here's an example. For my project, I analysed solutions in a triple quadrupole, spelt wrong, mass spectrometer with an attached ultra-pressure liquid chromatography unit. So this kind of can't spell quadrupole. They also misspell it elsewhere, so it's not unique to the single statement. And they seem to think that I'll be interested in a machine spec when really what I want to know about is them. Please, please do not put a machine spec in your personal statement. It's a waste of words. It doesn't show any understanding about the machine either, and I've probably used a cooler one. Bold claims. I ultimately had to teach myself band theory. Well, we'll be doing some questions on band theory then. In my IB extended essay, I explored multivarious, I think they mean multivariable, calculus. Excellent. A good topic for an extended essay. Should we test them? I now feel confident solving multidimensional problems in topological space. Let's. The problem with bold claims is that they invite a challenge. No matter how good a candidate is at band theory, calculus, or topology, the interviewer is going to have 3 or 4 years of undergraduate study, maybe a master's degree, 3 or 4 years postgraduate study, and probably 3 postdoctoral research placements of 1 to 5 years each ahead of them. They will be better, and they'll probably also really enjoy talking about it. If you're still writing your personal statement, here are some good alternatives to very bold claims. This prompted me to research aromatics and their importance in manufacturing pharmaceuticals. I am just beginning to understand that temperature is an average modelled with a Boltzmann distribution. I find the conflict between general relativity and quantum mechanics interesting because that's not news to me. So sometimes candidates just really want to share these cool science facts they've recently found out. electrons in the same orbital must have different spins. Yes? The authors described how sigma molecular orbitals in the same plane as vacant p orbitals can overlap, resulting in delocalization and lowering the energy of bonding electrons. And you mentioned this because the basic lock and key model describes the action of neurotransmitters on neurons. It does. It's also a potentially flawed model that there's been some debate about, and maybe you could write your opinions on that. I can go and read the books that you've talked about, but I'm reading your personal statement because I want to know about you. I can go and read the books that you mentioned, but I'm reading a personal statement because I want to know about you. So I want to tell me not the facts, not what you found out, but what you thought about them. Do you agree or disagree? Are you surprised by them? If you're interested and want to find out more, what have you done about that? How have you found out more? And what are the things that are really making you curious about it? I want to see some evidence of critical thinking, passion for the subject, and some integration of ideas and interest across the different fields within your subject. The best candidates might even identify subjects of debate and current challenges in research and express their opinions about these. Empty content. Candidates are always coming up with new and creative ways of saying nothing. I have read several books on the subject. Which books? Do you remember? What did you learn from them? I enjoyed the challenge of applying my chemistry skills in an unfamiliar context. Which skills? What context? What was the challenge? What did you find? What were your ideas? And vagueness can also be cunningly disguised as specificity, like this example here. This is from the chromatography student that we saw earlier. For my project, I analysed solutions in a triple quadrupole mass spectrometer with an attached ultra-pressure liquid chromatography unit. So this statement does tell us about the machine spec, but not what the solutions are, what they were looking for, how they interpreted the results, how good the data was, anything really except exactly what machine they were using. Question 2 in the C3L6 introduced me to the nuances of using mass spectrometer on polyatomic molecules. Weirdly specific. Weirdly. And seeing this, I would immediately ask them to draw a non-polyatomic molecule. Just see how they reacted. One of my personal bugbears on this topic is lists of privilege. These are the personal statements that are filled with lists and lists of different work experience placements, different project placements, awards, and presidentships to really obscure school clubs. So these describe students who had access to lots of things because they grew up with a supportive adult environment. And in my opinion, that means they actually have to work harder to prove their proficiency at a subject. And so you were born to wealthy parents and they sent you to a good school, right? Opportunities fell in your lap. So what did you do to earn them, and what more did you gain from them than somebody else would have gained in your place? The bottom line is, don't tell me what you did, tell me what you learned from it. If you're still writing your personal statement, make sure that every word says something specific about you. Give examples and justify your claims. Admitting your weaknesses. Needless to say, admitting your weaknesses in your personal statement is giving your interviewers ammunition to run with. And weirdly enough, it's not the things that you do say, but the things that you don't say that give us those clues. Okay, I have a mathematician here, and the statement that's caught my eye is considering real-life applications. You can also see mechanistic models, helical structures in nature. I tend to find mathematicians fall into two camps: the ones that love theory and the ones that love application. So here's a contrasting example. This candidate mentions a complex proof or puzzle, complex algebra or calculus, matrices and summations, and the music of primes. So this person is really, really theoretical, and they don't want to think about applications at all. Now, you will have to do both kinds of maths in the course, so let's do both kinds of maths, in particular the kind that you don't like so much. For a practical candidate, I'll do integration and differentiation, proof by induction, or the Gregorian calendar problem, which is a problem taken from an old math paper. For a theoretical candidate, I'll do mass mechanics, or if they've mentioned chemistry in their personal statement, a rates of reaction problem. If I'm feeling particularly mean, which is most of the time, I might do a physical problem with the theoretical student. So I might bring in something like a partially filled bottle of water, a ball of string, paper and scissors, or a balloon. I also like to come up with problems that will test their visual and spatial thinking skills, because these are very poorly developed during A-level, and it's something that I'm an expert in. That means in their personal statements, I'm looking out for too much mention of flat maths. And if I see it, I'm going to go all three-dimensional on them. Here's another one. The rate of substitution between bromomethane and chlorine ions in water can be 10 to the 4 times slower than the rate in propanone. Okay, I love this example because the candidate is already using scientific language like can be, and orders of magnitude rather than precise figures. So, let's look it up. This is exactly what your interviewers will do if you make a bold statement that they don't already know, assuming of course they have time. Right, I've found the book the candidate got this statement from, which explains the scientific language. It's Why Chemical Reactions Happen by James Keeler and Peter Wuthers. Wuthers, by the way, is one of the authors on the big bad chemistry textbook everyone gets if they're doing chemistry. It's this one, Organic Chemistry by Claydon, Greaves, Warren and Wuthers. It's very expensive, but try to get a second-hand copy online. Okay, so this book. It says here, the substitution reaction between bromomethane and chloride ions proceeds 10 to the 4 times faster in propanone, acetone, than water, and 10 to the 15 times faster when no solvent is present at all. So the candidate has reworded it a bit. It doesn't give any more detail, so I assume they don't know much more than that. But just above this line, it does talk about an SN2 mechanism. So I'm going to assume that they've read a massive chunk of this book and their organic chemistry is strong, that they're good at differentiating between SN1 and SN2 mechanisms, and I'm going to see if they can answer a question like this, where they will need to weigh up intermediate steps to explain the observed stereochemistry, or this, where we're going to derive a rate equation using the steady state approximation and explain how experimental data leads us to the derivation of SN1 and SN2. Your choice of interviewer also matters. So this candidate says, articles in Chemistry Review Catalysis excited me in how heterogeneous catalyst, zeolite, can act as a molecular sieve. They go on to say a bit more about it and how it can be used for environmentally friendly reasons. But I have a PhD in zeolite chemistry and their uses for environmental remediation of chromates and other toxins. So I'm going to know a lot more about this than they are. This example illustrates a really good point, which is that you should research who will interview you. To do that, all you need to do is research who the tutors are in your subject at the college which you're interested in applying to. And if you can, I would advise you to pick your college based upon what you found about those tutors, because they will be the people who will be your tutors when you go there, and your interviewers, or most of your interviewers, when you apply. It's of utmost importance that you match yourself as well as possible with the people you'll learn from, because that's exactly what they're trying to do in the interview process, match you to them. Okay, so this is a mock interview and this candidate couldn't possibly know that they were going to hear from me, but I still urge you to look people up and make your choices, if you can, based on the tutors. Needless to say, don't find out about their expertise and then write about it. They might then be encouraged to ask you about it and will know like 5,000 times more than you. But just be aware that the topics that they research and are really interested in are probably things that they might bring up in an interview context, if they can possibly pitch it at an appropriate level. So that's it from me. Thank you very much for watching. Here are some of my key points to summarise. Number 1. Check your spag. And don't put a machine spec in your personal statement. Number 2. Don't overestimate yourself or your knowledge. Number 3. Provide evidence of critical thinking. Give examples. Justify your claims and provide opinions. Number 4. Show that you're passionate about the subject and talk about ideas across the whole subject. Number 5. Talk about you. Not what you did, but what you learnt. And number 6. Know your interviewers. Let me finish with one more example. This candidate starts with their inspirations from early childhood. It's not technical, but it paints a lovely picture of a long and colourful journey through chemistry. They mention the Mentos experiment, the contraceptive pill, polymers, white phosphorus. They use various senses, colours, and it's just generally a very good piece of writing. It's personal and it pulls you in.